Hey, welcome to Unit 1. This is our first lesson in Unit 1, and we are going to work on graphing lines. Once we've done some work with the graphing just single lines, we're going to start solving equations of systems of equations by graphing. So we are going to learn how to graph, or just get refreshed on how to graph single lines, and then we're going to take that information and use it to graph two lines on one graph, which where they cross then will give us our solution. So I'm going to take a look here. Every class we're going to begin with a warm-up. Excuse me. And so on said warm-up, let's see here. On the warm-up, we are going to always work on some integers, positive, negative numbers. Then we're going to solve some equations, and then we'll get into the lesson. So the idea behind a warm-up is that you are seeing consistently and practicing consistently over time the rules and just skills that you need, and that will keep them fresh and you'll be sharp at them. So when we're working with integers, I have a positive 7 and a negative 1. This 7 is positive, this 1 is negative because of that sign. When our signs are different, we will subtract. So I'm going to say 7 minus 1 and get 6, and then we're going to keep the sign of the larger number. 7 is bigger, so it's a positive 6. Same thing here. So I have a negative 2 and a positive 1. My signs are different, which means I'll subtract. 2 minus 1 is 1. So we do 2 minus 1, and then I'm going to look, which number is bigger, my 2 or my 1? Well, 2 is bigger, so I'm going to keep the sign of the 2, which is negative. All right, a negative 7 and a positive 2. So again, my signs are different, which means I'm going to subtract. I'm going to say 7 minus 2 to get 5. And then I'm going to take my bigger number, and I'm going to look at the sign. Whatever the sign is, we keep it there, negative 5. All right, and I have a positive 3 and a negative 6. My signs are different. So when I'm looking at my signs are different, I'm looking here. Saying this is where my signs are different. So that means I'll subtract 6 minus 3, which gives us 3, and then I'm going to keep the sign of the larger number. So we're talking about absolute value larger. So 6 is larger, so that's a negative 3. Real quick, you could think about it on a number line. Negative 6. And I'm going to show you this two ways. So 1, 2, 3. Just a little bonus here. If we were to start at positive 3 and then go minus 6, so if I start at positive 3 and I go 1, 2, 3, 4, 5, 6, I land right here on negative 3, if you notice. That's what our answer was. The other way around on a number line, if I were to start at negative 6 and move plus 3 from there, if I start at negative 6 and I move plus 3, 1, 2, 3, I also land at the same spot. So for those of you that are visual, that might help you see kind of what we're doing with the integers. We will always practice these. You're going to be really good at them by the end of the semester, I promise. Okay, so there's two different sets of rules for integers when we're adding and subtracting. We say if it's the same sign, we add and keep the sign. If it's different signs, we subtract and then keep the sign of the larger number. For multiplying and dividing, it's a different set of rules. The same way that if you have an Xbox, the disk for the Xbox only works in the Xbox. If you have a PlayStation, the PlayStation disk only works for the PlayStation. You can't take a PlayStation game and put it in an Xbox and hope for it to work. That's the same way with these rules, with our sign rules. So when we multiply, our sign rules are, if it's the same sign, we'll get a positive answer, and if it's a different sign, we'll get a negative answer. So if we're looking here, these are different signs, which means we multiply 9 times 9. And different signs mean it's negative. Okay? So same signs mean we'll get a positive. Sorry, I was saying positive, so I wrote one down. Different signs mean we get a negative. So a negative 10, a positive 8, those are different signs. Our answer will be negative, and 10 times 8 is 80. Same rules apply for dividing. So if I have a negative 56 and a positive 8, I can divide those. 56 divided by 8 gets us 7, and my signs are different, so I get negative 7. And then finally, I have a positive 14 and a negative 2. My signs are different, so my answer is going to be negative. And then I divide these, I get 7, negative 7. Okay, one-step equations. These should have been covered in algebra, but we're going to continue to do them just so that you see them. So the first thing I'm looking for is, what do I need to get by itself? I need to get p alone. And right now there's a minus 5 that's hanging out with it. So I need to get rid of this minus 5. The way that we get rid of numbers that are on the same side is we do what's called the inverse operation. It just means we do the opposite. So the opposite of minus 5 is plus 5. And we would agree that that cancels out. But I have to keep this balanced. If I do plus 5 on my left side, I also have to add it to my right. And this is going to give us p equals a negative 17 plus 5. So remember our sign rules. A negative and a positive, different signs mean we subtract. So 17 minus 5 gives us 12. And then we keep the sign of the larger number. So that's why, part of the reason why we practice those sign rules. In fact, I'm sure many of you would attest to signs being one of the hardest parts in math. Okay? Right here, we need to get v by itself, and 7 is sitting right next to it, which means it's multiplying. So the way that we undo multiplying is to divide. So we're going to divide 7 from both sides. That makes those cancel out to become 1, or just 1v. And then, again, my sign rules. This is dividing, so I have a negative and a positive. When I divide, if my signs are different, I'm going to get a negative answer. And 28 divided by 7 is 4. We're not going to do all of these just for the sake of time. I added a bunch of them. Again, it's kind of new to all of us. So this one, I need to get n by itself. So I will subtract 13 to move it. Gets rid of it there. And then our sign rules, we have a positive 3 and a negative 13. They're subtracting, so they're different signs. So we are going to subtract to get 10, 13 minus 3, and then we're going to keep the sign of the bigger number. N equals negative 10. And I'm going to show you just one two-step equation here. This one, we have to undo two pieces. We have to undo the 6, and we have to undo the 4. The 4 is attached to the k through division. So anytime our number is attached with division or multiplication, we save it for the second step. We get rid of whatever is adding or subtracting first. So I have a 6 that is adding here, so I'm going to subtract it to get rid of 6. I just kind of move it over, or I do it to both sides, and that leaves me with k divided by 4 equals 1. Now k divided by 4, what is the opposite of divided by? Because that's all we're doing. We're taking our number and whatever is happening to it, we do the opposite or the inverse. So the opposite of dividing is to multiply. So I'm going to multiply 4 to both sides, and this is how I show it. And those end up canceling out to make 1k, or just k by itself. Means the same thing. And then 1 times 4 is 4. So there's my answer there. Okay, so that's our warm-up. We will do those kind of problems at the start of every lesson so that you see it, get familiar with it, and get good at it, okay? So here's what we're going to be doing. We're going to do a skill-building activity. Now there are 2 activities built in. The first one is that I'm going to go through and I'm going to state the slope, which is what we're going to call m. So I'm going to say m equals, and I'm going to state the y-intercept, or the b, for each line. And this is very simple. This is written in what's called slope-intercept form, and this should be review for you, but slope-intercept form is y equals mx plus b. So mx plus b is can be replaced here, or coordinates with the values in our equation. So check this out. I'm going to grab this and move it over. And so if you see here, my m is my number that's next to x, and my b is my term that's being added or subtracted at the end here. So all we really have to label is we're going to say m equals -1. There's a -1 right here next to x. b equals -3. That's it. So the number next to x is our m, or the value next to x is our m. So in this one, m equals -7/5. And our b is the number at the end, 3. So b equals 3. And that's all I'm going to do on each one of these. So m equals 9/5. I got that from here. It's the number next to x. b equals -4. m equals -3/4. I leave the sign with it. b equals 2. So again, my number next to x is my m. My number at the end is my b. So here's a good one. I have an m equals -5/1. I'm going to write it as a fraction. That's -5/1 like that. So I like to write these as fractions. And then b, I don't have a b value. There's nothing here, right? So b is 0. It's a little bit different than if we just had an x there. So if, let's see here. m equals 8, b equals -4. Hopefully, you're starting to feel really comfortable. Every time I zoom in here, you go, oh, this one's, I see it right there. m equals 5/3, b equals -1. m equals -4/3, b equals 4. See how quick we can identify this information? And that's really the hardest part. So I'm going to let you look at this, and a question's going to pop up. What does m equal? What does b equal? So m equal, b equal. Same thing. What does m equal? What does b equal? Okay. So m is our slope. When I say m, it's referring to the slope of a line. So when we graph it, we're going to see how that works. And we know how to identify that. That's -3/4. And b equals 1. So I have some new instructions here. I'm going to show you the direction of the slope with arrows and also state the y-intercept. So I stated the y-intercept here. There's one more thing now I'm going to do. If I have a negative, it's going to make me move down, and my denominator is always going to move right. So we talk about rise over run. You'd be familiar with that. So the top number tells us if we're going to move up or down. If it's positive, we move up. If it's negative, we move down. Our bottom number is always right. Okay, and then you'll see how it will change, but we'll do it later so that it makes sense. So m equals -5/4. So I'm taking this negative and I'm applying it to my top number. So -5/4, which means we're going to move down and then always right. b equals -1. So I'm saying m, here's this is a -1/1x. We don't see anything there, so it is a -1/1. Because there's still a 1x there. It's not a 0x. That doesn't say that. There's just an understood 1 there. And b equals this +1. And that's telling us down and right. So again, m equals, if we can do this part, so b equals 4, if we can do this part, graphing lines are pretty easy. No negative, so I'm going to go up and right. Okay, m equals, that is a negative 1 over 1. I'm looking here. This is a negative 1x. There's still 1x there. And then b equals, this one, there's nothing at the end here, so it's 0. So if we have an x with nothing, with no number, there's really a 1 there. If there's no number at the end, though, that's a 0 for b. And then we say down and right. I'm not going to make you write this every time. In fact, I don't know how I'm going to make you write it because we're distance learning, but this is a positive 6, positive 5. Notice that our b doesn't, this doesn't affect any of that. Okay, I'm just going to do a couple more. So we have m, let me stay with blue here, m equals negative 7 over 5. I'm just taking that negative, I'm giving it. So remember, a negative means it's going to go down. My bottom number always goes right. I'll show you when we'll go left in just a moment. b equals negative 3. Okay, hopefully you're like feeling really confident in this. I'm going to show you 20. m equals, if I just have a regular number, to write it as rise over run, I'm going to say 3 over 1. 3 is positive, we're always going right. Okay, hopefully this part made sense. Now all we're going to do is we're going to take that information and use it to graph. So we're going to take m equals, so I'm going to ignore my graph for a second here. Let's do what we just did. M equals 1 over 4. B equals negative 5. And this is a positive 1 over 4, so I'm going to count up and right. So now watch what we do. B tells us where to begin on the y-axis. So B is telling us where to begin. We're going to begin at negative 5. So I'm going to find negative 5, and I'm going to begin here at negative 5. I am not beginning on this negative 5 because that is my x-axis. I always need to begin on my y-axis, which is vertical, up and down. So I'm going to begin at negative 5, and my m tells me how to move from that point. Look, we made arrows. We're going to move up 1. We're going to move up 1 and then right 4. So if you can count, you can graph. We move up 1, that's to here, and then over 1, 2, 3, 4. And we can, we don't have enough room to go up 1 and right 4 again because we'll be off the graph. Now here's where I was telling you sometimes we can go left. We can also do the exact opposite. So I'm going to show you in purple. The exact opposite of up is down and right is left. So here's my exact opposite. I'm going to show you what happens in purple. The exact opposite, if I move down 1 and left 4, I get a point here, and that point, I'll use a line in blue here, that point, see if I had a line there, see how that point goes through my line? So I can either count up and right, or I can do the exact opposite and go down and left and end up at the same line. Okay, we're going to do a couple more of these and then that'll be it for this lesson. It probably feels kind of long. I will refine that, but just thank you for hanging in there with me today. So m equals negative 3 over 2, and we could do our arrows now if we want. We can say down 3, right 2. If I run out of room or I go off the graph, I can do the exact opposite, but I'll deal with that when I get there, if I get there. b equals 3. So check it out. We begin, b tells us where to begin at 3. So I'm going to go on my y-axis. I'm going to begin at 3 here. I do not begin on this 3, ever. So we're going to begin at 3. And now my m is telling me to move down 3. So I'm going to count 1, 2, 3 from that point. So I'm going to count down 1, 2, 3, and then right 2, 1, 2, and I can put another point. And we can do that over and over and over again. I can go down 3 again, 1, 2, 3, right 2, 1, 2, and put a point. Looks like I have room to do it one more time. This would be plenty of points, but let's do it one more time just to show. 1, 2, 3, 1, 2. So I have another point right on the corner there. And that's our line. We can add arrows to our line. We could keep counting. If the graph got bigger and bigger and bigger, we could keep going further and further. All right, last two, and we'll call it a lesson, okay? So again, look at how simple this is. As long as we're comfortable with identifying what our slope is, which is our number next to x, and what our y-intercept is, or our b, that's the number at the end. And then if we can make arrows that tell us we know what way to count, and then all we have to do is follow our steps here. So we're going to begin at -1, and then we count up 3, 1, 2, 3, right 1. We can do that over and over again. I can go 1, 2, 3, right 1. I can also do the exact opposite, which is down 3, left 1. And then I'll build a line. Cheater line. And that's it. Okay, so this will be the last one, and then the lesson's over. So again, we're going to label m equals, b equals. Our m is telling us -1 over 3, and our b is -1. Space that out a little bit better. And then our m tells us we're moving down and right. So I'm counting, I'm beginning at -1, and I move down 1, right 1, 2, 3, put a point. Do that again, down 1, right 1, 2, 3, put a point. Connect my points, draw some arrows, and we've graphed a line. So hopefully this was a helpful refresher on how to graph.